This is SAT Math Manual Section 10. Section 10 deals with systems of linear inequalities. In previous sections, we covered systems of linear equations, graphing linear equations. You must be familiar with those concepts before jumping into systems of linear inequalities. This particular section will rely heavily on information that we have covered in the preceding sections of this manual. Dealing with the system of inequalities first will require knowing how to graph a linear inequality. So that's what we're going to cover in this box here. I am going to highlight this right here. We need to talk about the four inequality symbols that you may encounter and what they imply, what they mean about the graph of the linear inequality. So let's start with a greater than symbol, and notice we have a greater than or equal to symbol on the right here, a greater than alone on the left here. When we have a greater than symbol, we are dealing with, let me zoom in here for a moment. When we have a greater than symbol as opposed to a greater than or equal symbol, we have a dashed or dotted or broken line, dashed line as opposed to a solid line. We'll get to that in a moment. And we are shading above the dashed line. So let's take a look at this linear inequality. Let's imagine first that we're dealing with an equal sign and not a greater than sign here. In other words, we'll deal with the line itself first, and then we'll deal with the shading. So what am I going to do? I'm going to use the y-intercept over here. Again, this was all covered in a previous section, not to mention the fact that by the time you are a sophomore, junior, senior, you have dealt with linear equations and graphing them over and over and over again, which of course means that most of you should be very familiar with all of this already, and that this should really be more review, and that is why I am moving through this stuff rather quickly without a lot of explanation. So again, I am going to use the y-intercept there, that +1, that's my y-intercept. The slope is 2, which means I have a rise over a run of 2, rise over a run of 2, run 1, rise 2, run 1, rise 2. Okay, so there's my line. So I'm going to dash a line through those points, roughly. So there's my dash line, sort of a line, a little bit curved, but that's okay. And we are shading above that line. So it is this area over here, this portion of the XY coordinate plane that we are shading. Over to the less than symbol, again, this is going to be a dashed line. And of course, less than means we are shading below. So we can do the same thing here. Let's make our dashed line, boom, 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 boom. And we are shading below the line this time. For greater than or equal to, now we change to a solid line. And again, greater than, we are shading above. So now the only difference between what we have over here and what we'll do here is now we have to have a solid, let me just draw one or two more points here, make it a little bit easier. So now we have a solid line and we are shading above. Some students may think we are shading to the left of the line. I would not think of it like that. I would think of shading above and below. Above the line, below the line. Next we have less than or equal to. This is going to be solid and we are shading below. If you want to put semicolons between these, make it a little bit easier to differentiate the two things we're talking about there, go ahead and do that. So what do we got here? We've got our solid line. We've got our solid line, and now we are shading below. So those are the four options that you will encounter when you are graphing a linear inequality. And now we need to add another linear inequality to create a system. That is what a system of linear inequalities is. It is simply two linear inequalities that we need to deal with at the same time, just like we learned in systems of linear equations. What we are looking to find, what we are looking to do generally when we solve a system of linear inequalities is we're trying to find the solution set, and that solution set is the area of overlap, between the two linear inequalities that we have graphed. So here's what we're going to do. We're going to take one of the linear inequalities that we dealt with above, which we've already graphed here. This is y is greater than or equal to, so we have the solid line and we have shading above, 2x plus 1. And we're going to add another linear inequality here, that is y is less than or equal to negative x. If you have done the graphing linear equations section, you really should remember this anyway. If you don't know it, you need to get it memorized, that the line y equals negative x is this line here. It is a line that goes through the origin and has a slope of -1. So I am going to draw that line in. It is solid because I have the or equal to here, and where am I shading? I am shading below that line. Now some of you, most of you, all of you can already see where the area of overlap is, and that's great, but we are going to run through this just so that we are really sure of how we can determine this on test day, how we can prove where the solution set to the system is. So we basically have 4 regions here. We have this region up here. It's sort of like the northern portion of the intersection. So up here we have the northern portion. Let's say over here we have the eastern portion. Down here we have the southern portion. And then over here on the left, where we have the overlap, of course, we have the western portion. So we have split the xy coordinate plane into 4 regions. The green region up here, the northern portion, contains point A, so we're calling that region A. And by the way, we've just chosen 0, 3, 3, 0, 0, -3. We've just chosen these points because they are easy points to plug into the inequalities here. There's nothing special about these points A, B, C, D. We could choose any point from these 4 regions that we are looking at. And what we can see about the point 0, 3 is this. 0, 3, when we plug, remember this is an x value, this is a y value. We have previously talked about the fact that when we are given a coordinate with an x value and a y value, we can substitute. We can throw that x and y value into whatever equations, or in this case inequalities, we have. So I'm taking the 3 value, throwing it in for the y. I'm taking the 0 value, throwing it in for the x, and what I get is I get that 3 is greater than or equal to 1. So inequality 1 is satisfied. In other words, that point A is in the solution set of inequality 1. But for inequality 2, when 3 and 0 go in, we get 3 is less than -0, which is just 0. 3 is less than or equal to 0. That is not true. So in this region up here, we have inequality 1 satisfied, but inequality 2 not satisfied, which means that point A and all of the points in region A are not part of the solution set of this system. They are part of the solution set of one of the 2 inequalities in the system, but not both. And that's what a solution set is. It is the set of all points, or the region on the graph, that contains all of the points that satisfy both of the inequalities in the system. Let's really quickly run through the rest of these. Point B down here in this southern portion, the orange portion, watch what happens. We throw in -3, we throw in 0 for x, so the 2x just goes away. So I'm just going to do -3 is greater than or equal to 1. Y is -3, x is 0, so we get -3 is greater than or equal to, the 2x just goes away, greater than or equal to 1. That is not true. So in this orange region, already we can see that this orange region is not going to be the solution set to the system, because one of the 2 equations is not satisfied. We don't even need to work through this other one. This second equation, second inequality, will be satisfied. Occasionally you will hear me switching back and forth between equation and inequality. I apologize for that. I'm trying to go quickly so that we can get through all of this stuff. And when I do that, I occasionally say crazy things, so I apologize for that. Sue me. Point C in this easterly region, this blue region over here, when we throw in point C from this that easterly or blue region there, what ends up happening if we send this is our y, this is our x. When we send 0 in for y and we send 3 in for x, that is going to be 0 is greater than or equal to 7. And last I checked, that is not true, which means, again, equation 1 is not satisfied. Equation 2, inequality 2, sorry, my fault, once again. Inequality 2 will also not be satisfied. We can see that very simply. This is going to be 0 is less than or equal to -3. 0 is not less than or equal to -3. And then finally, we get around to this westerly region, the purple region, the region that we already said is the overlapping region. And when we throw in -3, 0, we go 0 greater than or equal to 2 times -3 plus 1. That is 0 is greater than or equal to, this is -6 plus 1, which is -5. And indeed, that is true. And then over here, we have 0 is less than or equal to -3, right? Negative, and then when x is -3, so we've got -3, which is 0 is less than or equal to 3, also satisfied. So by throwing in a bunch of points from these regions that are created, these 4 regions that are created when these two lines or inequalities intersect, we can see that point D, and indeed all of the points in this region, and remember that this region is infinite because this xy plane would go on and on and on, even though we can't see the entire thing here. This region would contain all of the points that would satisfy both inequality 1 and inequality 2, which means that this region is the solution set of the system of linear inequalities. On the next page, we will actually dive into the ways, the methods that we can solve systems of linear inequalities now that we know what it means to solve a system. So the first method is the maybe most traditional method, the most conventional method, which is the graphing method, which is kind of what we did on the previous page. We just sketched the system, we graphed the lines, we did the shading, we found the region of overlap. That's what we're going to do in example 1 here. You may want to pause the video and try to do this example on your own. Of course, if you are not so confident or you would just like to watch me work through this first, that's fine too. So what are we doing here? We are going to graph both of these systems, both of these inequalities. Inequality 1 is y equals, remember first we'll just deal with the line, equals x plus 2, so a y-intercept of 2 and a slope of 1, a rise over run of 1. So over 1 up 1, over 1 down 1. So what line do we have? We have this line, and that line is solid because we have a greater than or equal to symbol here. And now the shading, remember that greater than we do shade above the line. So I'm going to shade over here. And now the second line is in standard form, not slope-intercept form like the first line or inequality was. So what do I do here? Yes, I could do the algebra, rearrange this so that inequality 2 is in slope-intercept form, but we did learn a shortcut for situations like this, and that shortcut is probably a little bit easier, less time-consuming than rearranging all this algebraically. Remember, the shortcut is that the slope of a line in standard form equals -a over b. In this case, that is going to be, this is my a, this is my b, this is my c. So -2 over 3. -2 over 3 is going to be my slope. My y-intercept is c over b. That is 6 over 3. c over b. So that is 6 over 3, which of course is 2. So what do? I go right there to 2 again. That's my y-intercept. And now my slope, rise over run, is 2 over 3, but the line is negative. Remember, a negatively sloped line looks like this. So I'm going to do a run of 2 and a rise of 3. And again, I'm just looking at the horizontal distance needs to be 2, the vertical distance needs to be 3, and I know my line needs to go like this, so I'm putting the point down here rather than up here. So this line is going to look something like this, and I am shading how. In this case, I might want to just think about the fact that if I were to rearrange this equation and isolate my y on the left, everything else would be over there on the right, which means I would be dealing with a y is less than or equal to a bunch of stuff. So less than or equal to means that Once again, the line is solid, and I am shading below the line. So once again, I can see that my solution set is this westerly portion of the xy plane. All of the points in this region here where the two inequalities in my systems overlap, that is going to be the area of solution. That is going to be the area that contains all of the points that will satisfy both of the inequalities in my system. Another method, the NITAS method. Remember that NITAS is one of our tin techniques. This is a tin method. Occasionally, a question will simply ask if a particular point is in the solution set of the system. If you see a question like that, it may be easiest for you to simply take the point that they are asking you about and plug that point into both of the inequalities. Remember that a system of linear inequalities is satisfied when the point satisfies both of the inequalities in the system. So in example 4, keep in mind this is a no calculator example, you might want to try this on your own if you have some sense of what it would mean to NITAS on a question like this. If not, I'm going to work through it right now. In the xy plane, point A is contained in the graph of the solution set of the system of inequalities above. Which of the following could be the coordinates of point A? So basically they're saying that A is in the solution set, which means that A must satisfy both equation 1 and equation 2, or inequality 1 and inequality 2. So what I'm going to do is I'm going to make a little t-chart here, which is what I'm supposed to do in NITAS. I am going to label the first column A for the coordinates of point A. Generally with NITAS, we're supposed to start at answer choice C. In this particular case, it does not matter where you start. You can't really get bigger or smaller, which is why we generally start at C, because we usually would move to an answer that will produce a larger or smaller result. In this case, you can really start wherever you want. I'm actually going to start at answer choice A because 0 and 0 are going to make my life really, really simple. So what I'm going to do is I'm going to label this inequality 1 and this inequality 2. I'm going to put a 1 here and a 2 here, and I'm going to ask myself, does 0, 0 satisfy inequality 1? Well, I would have 0 is greater than or equal to, the 2x is going to go away because 2 times 0 is 0. 0 is greater than or equal to negative 1. 0 is indeed greater than or equal to negative 1, which means my first inequality is satisfied. What about 0, 0 in inequality 2? This would be 0 minus 0. That's just 0 is less than negative 1. That is not true. 0 is not less than negative 1. So we have a point 0, 0 that satisfies only one of our two inequalities. So answer choice A is gone. Let me go to answer choice B, 0, negative 2. So for inequality 1, what do I have? I have negative 2 going in for y. Negative 2 going in for y is greater than or equal to negative 1. That is not true. Negative 2 is less than negative 1. Negative 2 is not greater than or equal to negative 1. So that answer choice is out. Answer choice C is negative 2 comma 0. Negative 2 comma 0 for the first inequality. The 0 goes in for y. And then I have 0 is greater than negative 2 times 2 is negative 4 minus 1 is negative 5. Indeed, that does work. 0 is greater than or equal to negative 5. When negative 2, 0 goes into the second equation, I have negative 2, which is my x, minus 0, which is my y, x, y. X, y is less than negative 1, and I get negative 2 is less than negative 1. That is indeed true, which means that answer choice C must be the coordinates of point A, as the coordinates in point C satisfy both of the inequalities in the system. That is how we might use NITAS on a system of linear inequalities. On the next page, we need to talk about systems of linear inequalities, word problems, or translation. A lot of times when we're talking about word problems, we are talking about translation. We did do a few examples revolving around the same concept in a previous section in systems of linear equations, where we took a word question and made a linear function or a linear equation out of the words in the question. Systems of linear inequalities will be possibly slightly trickier, but again, for most of you, this should really just be review. This should not be anything new. Key translations for inequality word problems. We need to understand what all of these words on the left will translate to symbolically. You might want to run through these on your own, see if you can get these without my telling you. At least, no less than, a minimum of, that means greater than or equal to. If you say that John has at least $10, that means that he has 10 or more. His amount of money is greater than or equal to $10. At most, no more than, a maximum of, that is less than or equal to. More than is greater than or equal to. If John has more than $10, he can no longer have exactly $10. He must have above $10. And then less than, under, that would be less than, obviously. So again, we need to be able to recognize when we are dealing with wording that indicates or implies certain symbols. Let's now jump down to example 2, in which we will actually do some translations using the information we just went over. Before we start, I just want to point out, you do see no more than, you see over, you see at least. Anytime you see wording like that in a question, there is a very high probability you're going to be needing to translate the worded scenarios into an inequality. These phrases that I just underlined are obviously in the chart we just went over. You also want to remember, we made this note in a previous section, that when you do translations on this test, when you are converting word problems into an equation or inequality, you do want to make sure you're using appropriate letters for the unknowns. Don't just use the generic X and Y. If a question talks about, for instance, babysitting hours and tutoring hours, you're going to want to use B and T, not X and Y. Make it a little bit easier for your eyes and your brain to keep track of what's going on. You might want to pause the video and try these 3 examples on your own. I am going to work through them right now. So in example 2A, we have Harriet babysitting and tutoring for no more than 20 hours per week. So what I'm going to do is I'm going to make B her babysitting hours, and I'm going to make T her tutoring hours. So I have B babysitting hours and T tutoring hours, and the question is telling me that the sum of those must be no more than 20 hours per week. Remember that no more than 20 hours per week means less than or equal to 20. The total number of babysitting and tutoring hours could be 20, it just can't be over 20. So this is a less than or equal to scenario, and my translated inequality will be B plus T is less than or equal to 20. In example 2B, we have Ricardo. He is a car salesman. He sells electric vehicles, which cost $30,000 each, hybrids, which cost $25,000 each, and last month the total value of the cars he sold was over $400,000. So I'm going to use an E for electric vehicles. I'm going to use an H for hybrids. So, and that's the number of electric vehicles and the number of hybrids. So the value of the electric vehicles he sold will be that $30,000 times the number of electric vehicles. So 30,000 E will be the value of the electric vehicles. I'm going to add to that because I'm looking at the total value of the cars he sold. So the hybrids will be 25,000 times H. So again, value of the electric vehicles, value of the hybrids. When we add those together, we need to be over 400,000. Not equal to or over, not at least, but over 400,000. So 400,000 itself is not included. We must be over or above 400,000. So what do we have? We have, try to squeeze this in here, 30,000 E plus 25,000 H is greater than 400,000. That squeezing didn't work very well, but that's okay. The third example here, example 2C, this is definitely the trickiest one of the bunch. The wording here definitely can throw students for a loop, the at least, the twice as many. So first things first, I'm going to think of this as an is scenario. I'm not going to think of this as an at least scenario. I'm just going to say Min purchased twice as many pounds of pasta as pounds of coleslaw. Now even that, so again, I'm just ignoring the at least for for a moment, even that statement can be a little bit trippy. So one of the things you can do to help your mind out here is you can tin to help you see what the relationship is here. Let's do this. Let's say P will be the pounds of pasta and C will be the pounds of coleslaw. So if coleslaw was, let's say, 2 pounds, okay, and this says Min purchased twice as many pounds of pasta as pounds of coleslaw, it should be pretty obvious that pounds of pasta would need to be 4 pounds. This is twice as many as this. So first of all, in terms of where the coefficient of 2, remember if you're twicing something, if you're doubling something, there's got to be a coefficient of 2. So the position in which that 2 should go has to be here, right? Because we threw in 4 and 2, so only the 2 here would make sense. This would be 4 equals 2 times 2. Again, remember, I'm ignoring the at least for now. So if this were just a simple Min purchased twice as many pounds of pasta as pounds of coleslaw, this would be that P is twice C. Number of pounds of pasta is twice coleslaw. Now, when we bring back in the at least, this should actually be pretty simple. P must be at least twice as many pounds. So we keep the equal sign, and we know that P has to be either equal to 2C or P could be greater than 2C. So for instance, remember with the at least, this number 4 could actually be 5 or it could be 6. So P doesn't need to be equal to, obviously, 2C. P needs to be either equal to twice C or P could be greater than twice C. Twice C would be 4. P could equal 4. P could equal 5. P could equal 6. So again, this is P must be greater than or equal to twice C. Twice C. P greater than or equal to twice C. Again, if you saw the relationship there immediately, more power to you. I do understand, however, that some students do get a little bit tripped up by the type of wording that we see here in example 2C. Down at the bottom of the page, we have number 19, in which we are going to combine one of the translations that we just made in example 2 above with another linear inequality to form a system. And the somewhat interesting thing about number 19, if you find anything interesting about an SAT question, is that we don't actually have to solve anything here. We don't have to solve any system. We just have to create the system with translation. And in fact, you will see a good number of linear equation system questions and linear inequality system questions on which you do not actually need to solve anything. You just need to create the system. You might want to pause the video and do number 19 on your own. I'm going to work through it right now. We've got Ricardo again, car salesman, sells electric vehicles at $30,000 each, hybrids at $25,000 each. Last month his goal was to sell at least 15 vehicles. You've got some linear inequality language there that we'll need to translate. While he did not meet his goal, the total values of the cars he sold was over $400,000. Which of the following inequalities describes X, the possible number of electric vehicles, and Y, the possible numbers of hybrids that Ricardo sold last month? I'm just going to circle inequalities here. That's what we're looking for. We're looking for the correct inequalities. So one of the two inequalities here is one that we've already done in the previous example. We did $30,000. That was the cost per electric vehicle. Now we used E above here. The question requires us to use X, the possible number of electric vehicles. So I am going to have to use an X here. And so that will be the total amount, the total value of the electric vehicles sold. Then we have the total value of the hybrid vehicle sold. That's $25,000 per hybrid, Y hybrid. So I've got to multiply that 25,000 times the number of hybrids, Y. If I add those together, I will get the total value. This sum would represent the total value of the cars that he sold, and we are told that that value was over, not at least, not over or equal to, but over $400,000. So that's one of our two inequalities. We can jump to the answer choices and immediately eliminate answer choice A and D. Not a bad idea, just to make this go a little bit more efficiently, possibly. We know now we cannot have A or D being the correct answer because we have the wrong inequality sign. We have a less than in both of those answer choices instead of what we need, which is a greater than. So the second inequality in both of those answers does not work. Now we have to deal with the other inequality, and the other inequality comes from this information in the question. This is the new information that we're given that we were not given in example 2 above. So now we have his goal was to sell at least 15 vehicles. So what that means is that the number of electric vehicles plus the number of hybrid vehicles, why? He wanted, his goal was to sell at least, which is greater than or equal to 15. But then we get this information here that says he did not meet his goal. So he did not do this, which means what he must have done is he must have sold less than 15 total vehicles, because if he had sold 15 or greater, he would have met his goal. If he did not meet his goal, that means he must have sold less than 15. So there's our first inequality, there's our second inequality, and we can see x plus y is less than 15, x plus y is less than 15. Answer choice B contains this was our first one, this is our correct second one. So answer choice B contains the system that we need, the system that describes all of the information in this question. Every now and then, this is top of the next page, every now and then you're going to get a system of inequalities that contains more than 2 inequalities. So far we've only seen cases where we have 2 inequalities, but we may get questions where there are more, and that's fine. These are just questions on which we need to go a phrase at a time, and we need to take what is said in the question and translate what is said into the appropriate inequalities. On number 9, which will not be all that much different from number 19, the previous question, we just have to go through the question, take what they are giving us, take the information they are giving us, and make some inequalities out of that information. Do number 9 on your own, pause the video. So in number 9, we have Sylvia. She needs to purchase 45 advertisements for a marketing campaign. We will have posters that are $15 each, online ads that are $20 each. She has a budget that is no more than $570. Again, there's the language. We've got at least, we've got no more than, so we know they're testing us on linear inequalities. We can see that from the answer choices as well. She must purchase at least, there's more of that language, 4 posters and 7 online ads. Which of the following systems represents the conditions described if X is posters and Y is online ads? So let's just circle which system of inequalities. That is what they're asking us. I'm going to start with this phrase right here. Why am I going to start with that phrase? Because that phrase has, it's actually 2 phrases. Those 2 phrases have really simple inequalities for us. We know that she has to purchase at least 4 posters. If X is the number of posters, X is at least 4. X has to be greater than or equal to 4. And I'll go ahead and I'll do the online ads. We could go to the answers and start eliminating some answers based on the X is greater than or equal to 4. But I'm going to go to the at least 7 online ads. So that means Y must be greater than or equal to 7. So let's see if there are any answers that we can eliminate just based on these 2 inequalities, and indeed there are. We have answer choice, let me zoom out here a little bit more. We have answer choices C and D that do not contain the correct inequalities. We have X is greater than or equal to 4 and Y is greater than or equal to 7, and answer choices C and D flip the sign to a less than or equal to. So C and D are gone, and now we just need to worry about A and B. What is probably the next easiest thing to do would be this phrase. Sylvia needs to purchase at least 45 advertisements, and the advertisements are posters and online ads. So that means that the number of posters plus the number of online ads, X plus Y, number of posters, number of online ads, has to be greater than or equal to 45. And beautiful thing about this question, and a lot of questions like it, is we don't even need to worry about the last inequality here. We can see that answer choice B, as opposed to answer choice A, has the greater than or equal to, which corresponds to the at least that we need, and the answer must be B. And again, don't even really need to worry about what is the toughest inequality. It's not uncommon that this will happen, where if you just attack one inequality at a time, and preferably the easier inequalities first, you may not even need to deal with the harder or hardest inequalities. That is it for systems of linear inequalities. So you'll need to know how to graph a linear inequality. You will then need to know how to graph a system of linear inequalities, or possibly how to use NITAS to solve a system. You'll need to know how to translate. So a bunch of things you need to be familiar with, need to be aware of. As long as you are, you should be fine on system of inequalities questions.